Hey guys, welcome to a discussion on scientific notation. Just want to go through this quickly, as quickly as we can. I know it may be may have been a while since you've seen this, but you definitely should have seen this before if you've had at least Algebra 1. You need to be able to use scientific notation in chemistry, because in chemistry we're often dealing with very small things, right? We're dealing with atoms and molecules, and there are a lot of them, right? If we have 1 gram of a substance and we need to count the number of molecules in that 1 gram, it's a really big number, okay? And so scientific notation gives us a way to represent that really big number in a more concise, compact manner, right? So take, for example, this number here. We have, it's 230 billion, 450 million, and you've got all these zeros after. It's really long to write all that out. Look at the scientific notation version, so much more compact, so much easier to read. We don't have to count zeros and make sure we know how many there are exactly. So that's why scientific notation is so handy. Um, I need you to be able to convert back and forth between what we refer to as standard form versus scientific notation, right? I could give you either one of those. If I give you standard form, you could go to scientific notation and vice versa. You need to be able to do that. So you'll notice that scientific notation always looks like this form here. It's got a number in the front, right? The two, like the 2 here. It may or may not have a decimal followed by additional numbers, but what it will always have, in addition to that number in the front, is it will always have the number times 10 to some power. You can see from comparing these two that the power may be positive, like it is here, positive 11, or it may be negative. All right. Something else to note regarding those values: if the number is positive, if the exponent's positive, I'm sorry, yeah, if the exponent is positive, like it is here, like it is with the 11, then the number in standard form will always be bigger than 1, okay? It'll always be greater than 1. If the number, however, is a negative exponent, like it is here with the -8, then the number here is going to be less than 1. It's going to be between 0 and 1, okay? So just something to keep in mind. Positive exponent means a number bigger than 1. Negative exponent means a number less than 1. And so that'll be a way for you to just kind of do a quick check when you do a conversion to make sure that you didn't do something wrong, okay? How do you convert between the two? Well, let me show you. We have this really large number here, and we want to write it in scientific notation. So like I said, with scientific notation, you always have a single digit in the front followed by a decimal. So we basically want a decimal here. Now, you never include trailing zeros in scientific notation. So we want to take this portion of the number only, all the way. I just passed the 5 there. I didn't quite draw that correctly. So just past the 5, ignoring these zeros here, okay? So how would we do that if we want a decimal here? Well, look at how many spaces, if we were to hop spaces between these numbers as we went to the end of this number, how many spaces would it be? If I want the decimal place to be here, let's think about it. So hopping to the end of the number: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. All right. So as we hop, take this decimal and move it to the right, we move 11 spaces. Look, that's exactly what this number is on the exponent here. So you're always going to be hopping some number of spaces that equals the number that's in the exponent there. Same thing is true if it's negative. It's just you go, and if the exponent's negative, you go in the opposite direction. So if you think about we want the number to be here, right? And so in order to get to where the number was previously, we would hop 1, 2, 3, 4, 5, 6, 7, 8 spaces. And so that's where the 8 comes from here. That's exactly the number that's on the exponent. All right. So let's do a couple of quick examples that aren't already written down for you. Let's say I gave you, maybe this will just, if it's still a little confusing to you, maybe this will help you see it. Let's say I gave you a number. We won't do one that's too large this time. 12. Let's just do 12,000. I give you the number 12,000 in standard form, and I say I want you to write that in scientific notation. In scientific notation, it would be 1.2. Again, we're only taking the numbers that are non-zero numbers. We don't include the trailing zeros. If there happened to be a zero in between here, then we would include it. But we don't include any of these trailing zeros here. Okay, so it's just the 1 and the 2. But it's always a number followed by a decimal, okay, times 10 to some power. So what is the power of 10 going to be? Well, we can see by this number here, because it's greater than 1, that we know the exponent on the 10 has got to be a positive value. But how many places are we going to hop to get there? Well, we want the decimal place to be here. So we hop to the end of number 1, 2, 3, 4 spaces. And so that gives us a value of 10 to the 4th. So 1.2 1.2 times 10 to the 4 would be the scientific notation version of 12,000. Let me just remove the decimal place there so that's not confusing to you. Okay, let's go in the opposite direction. Let's say that I gave you the number in scientific notation first, and I wanted you to give me the decimal form. So 3.03 times 10 to the 6th power. All right. So we're going to have 303. We know that's going to be in there. Again, because this is a positive value on the exponent, because the 6 is positive, we know then that this number is going to be greater than 1. Whoops. So it's going to be, we're going to have, we're not going to have a decimal, way out over here padded by zeros. We're going to have zeros at the end of this guy. And how many zeros? Well, let's see how many hops it takes. We want the decimal place to be, if the decimal is here in scientific notation, how many places do we hop to get to, as we're going to the right? We got to hop 6 places. So let's go 1, 2, 3, 4, 5, 6. So we just fill in enough zeros so that we've hopped that many places to the right. So our final value is, let's put the commas in there so we can see the actual number in standard form. In standard form, 3.03 times 10 to the 6 would be 3,030,000. Okay. What about a negative number? Let's give you a negative exponent here. 1.24 times 10 to the negative 3. Okay. So this time what we're going to do is we're going to take the 124, and it's a negative exponent. So we know that this number here has got to be smaller than 1. So what we're going to be doing is hopping to the left to see how many zeros we need to pad this number with. So it's, the decimal is right here in scientific notation. So we go 1, 2, 3 places to the left. Why? Because the exponent right here is a negative 3. All right. So we just pad it with zeros and then put a decimal right here in the front. So the final value of 1.24 times 10 to the negative 3 in standard form would be 0.00124. And you could put the 0 in the front or not. That's totally up to you. All right, let me give you let's start off with a decimal. 0.0000304. All right. How would you write that in scientific notation? Well, you would say 3.04, right? Single digit in the front, followed by a decimal, and then all of the other numbers, not including any trailing zeros. If this number happened to be like this, we would still write it like this over here, because we would leave off this trailing zero here. Okay. So how many places? So it's going to be times 10 to the, we know since this number is less than 1, then it's going to be a negative value on the exponent. What would the numeral be? Well, we got to see how many hops it takes to get to this position here, because we want to get 3.04. So we got to move the decimal place over to there. So we go 1, 2, 3, 4, 5, 6 places. So it would be 3.04 times 10 to the negative 6. All right. Hopefully that shed some light on it. If you haven't seen scientific notation in a while, you can rewatch the video. Khan Academy's got some examples online, so feel free to look those up as well. But this is something you definitely need to know before the school year starts, because we just don't have time to go over it in class. All right. As always, let me know if you have any questions, and have a great day.